GM, everyone. Welcome to the next session of All Things Somnia during Somnia Dreamathon. I am Ellis from Crack Labs. We're your hosts, and today joining us is Oliver. Oliver is going to give a little bit of background on the Somnia Data Streams release. You guys all got a copy of that in the Discord channel a little bit earlier. Going to get some good information in terms of how you can implement it into your projects. And for those of you that are not in the incubator, just a little bit of context. Dreamathon is the pilot native incubator for Somnia Network. We are building things, all things InfoFi, DeFi, GameFi, SocialFi. Really badass projects coming through the incubation at this point, and we are excited to have Oliver on with us today to enlighten us. Oliver, say hi.
Hi, how's it going? It's great to be here. It's great to be part of Somnia Data Streams. Do you want a little background on me?
Yeah, please tell us about M Squared. Tell us about you.
Yeah, sure. So by day, I am the head of product at M Squared, and M Squared is a very close partner with Somnia. We do a lot of interesting work in terms of exploring the potential use cases for blockchain of this kind of scale and speed. Our main sort of areas of focus on infrastructure for interoperable virtual world. So the metaverse, basically. How do you maximize the value of your on-chain assets? How do you bring them into different experiences? Yes, Somnia Data Streams was sort of born out of a project that M Squared did, which I'll talk a little bit about in the presentation. And so bringing it into the node, into the full Somnia ecosystem has been really good. I have a background in video games development. I spent 7 years as a video game producer on various titles. I have a background in AI research, and I've spent the last 5 years working for Linux operating system called Ubuntu as well. So the world of open source, the world of data, the world of video games is something very familiar to me. So yeah, this is a real match made in heaven.
I was going to say, it sounds like a match made in heaven for Somnia, that's for sure.
Yes, well
we're super excited to dive in. So with that, I'm going to just hop off. The floor is yours. For those of you listening, do drop questions in the chat. We will come back. We will do Q&A at the end. And for those of you that are builders in Dreamathon, if you have specific technical questions, we'll try to get the ones we can answered today.
Yeah, drop them in the comments. I'll keep an eye on as we go, and if things come up, I'll try and answer them as I see them. Otherwise, I'll go through at the end.
Fantastic. Well, Oliver, the stage is yours.
Great. Okay, let's bring on my slides. So yes, this is Somnia Data Streams, and sort of the topic of this talk is about real-time on-chain data for the next generation of dApps. One of the interesting things about blockchain development is it's inherently useful to have data on chain, but accessing that data and writing that data is challenging. It's not just challenging, but it's also expensive. You often have to build supplementary infrastructure to be able to query and modify and rewrite that data, and often adopting a Web3 angle to your applications or your video games it inherently adds extra cost, because you have benefits with things like on-chain storage being transparent and verifiable, but the ability to query that data at speed and be confident in that data being accurate is inherently challenging. So you often rely on things like off-chain databases, indexers, which are faster, they're cheaper, but you're losing one of the advantages of the blockchain, which is that verifiability. You're centralizing your point of interacting with that data, and then you're constantly having to run infrastructure to poll the nodes, make sure your data is up to date, make sure that any assumptions you've made in the meantime are still correct, which makes it difficult to scale. And Somnia being something that operates at such speeds, this issue is, compounded and exponentially more complicated. And so that's really where we went with Somnia Data Streams, which is a node level protocol for real-time structured on-chain data with built-in reactivity. And that's quite a lot of stuff there, and there's quite a few components here. And I've tried to break it down. I've got some examples a bit further on, an example that you can participate in as well. But these are really the key features. So one is instant updates. So rather than needing to poll the chain for changes, you can subscribe to events on chain via a WebSocket, which essentially means you're getting push notifications on events emitted from on-chain data. And that means not only can you subscribe to events to get notified for changes, removing the need for polling, but you can also attach to those events supplementary metadata via ETH calls. So this could be things like this user wants to get some Somnia testnet tokens from the Somnia faucet, and here is their current wallet balance. So you can get that information straight away without having to query it again to know whether they qualify for additional testnet tokens. The other thing is structured schemas. So this is basically making it easier for Web2 developers to onboard blockchain data into their applications. So this is the ability, using our SDK, to define data schemas that then take your data, write it to chain in the structured format, as if you were working with, something like PlayFab, for example, in the video game space, without needing to understand or work directly with Solidity. So you can register new schemas for your data formats, or you can look at schemas that already exist on chain and write data to that. So for example, you may have a GPS schema that is on chain that has, XYZ coordinates, and that could be used by a Formula One race car. It could be used by flight radar. It could be used by a delivery tracking app, and they can onboard their data onto the chain without needing to worry about that structured data. And because they're using shared schemas, you can think about all sorts of cross-application use cases for having data sources that adhere to a consistent style and format, which is what sort of hits on the composability aspect. That makes it more efficient because you're optimizing storage using our data streams contracts, and with the event emission, you are saving money and compute costs, polling the chain and running indexes as well. And that means you're getting raw data direct from the chain with all of the guarantees that come with interacting with that. So we think that this architecture has all sorts of applications in all sorts of areas, and this is really like the base level primitives for building a real event-driven InfoFi based economy that is on chain. So you can imagine in gaming, you can have things like real-time multiplayer. You can have synced state across game shards. You can have assets that are portable and movable across games. You can grant rewards in a verifiable way. You can have live leaderboards. You can even start to think about things like ELO ranking, which is actually relatively complicated to do on chain because you need to look at the relative scores of players and make certain calculations. I'll talk a little bit about what we do there in the architecture section. You think about location, weather data, you can have proof of delivery, fleet coordination, auto resolving, customs charges or delivery fees, when goods are proven to be delivered. In the DeFi space, you can imagine things like auto liquidation, subscribing to price events and then making changes to your portfolio accordingly. Sports betting and prediction markets, I think, is actually one of the most exciting applications. Being able to deal with live data feeds from a sports event, compose and create markets on chain and have them resolve instantly without any middlemen, I think is super interesting. And then you can go into more industrial spaces, think about things like digital twins, IoT devices, device telemetry, that sort of thing. And then real-time, collaboration and creativity on chain, things like on-chain reputation scores, stuff like that. So yeah, there's a lot of different applications, and I'm sort of interested in where people go with it. And you can imagine communities around each of these different disciplines and areas, working together to essentially crowdsource what the ideal schemas and data structures for making this data maximally useful and accessible and discoverable would be. And this is actually, Data Streams came out of a project the weird M Squared made called Chunked. I don't know if you folks know about it. And this was our challenge to go, okay, Somnia is this fast. It's so fast that it could actually work as the back end for a fully on-chain game. And Chunked is essentially a sort of Minecraft style game, but where absolutely everything you do is recorded on chain. So that includes, movement. Every block in the world is registered on chain. Blocks being mined, crafting, all of that sort of stuff. And we put that out as a bit of an experiment. And to make that work, we needed essentially what Data Streams is now. We called it Etherbase back then. And that was the ability to register game events and subscribe to game events, at speed and at scale. And the fact that a lot of that technology that we sort of prototyped with this project sort of proved itself to be more generally useful, we brought that into the node. So with enhanced reactivity, and I'll talk a bit more about reactivity in a second, to make experiences like this accessible to every developer. So I'm going to dive in. I'm going to get a bit technical and just talk about the components that make up Data Streams, because there's 3 or 4 sort of distinct components here that are worth talking about. So the first concept is reactivity. So in a traditional chain, you would have a contract that emits events, and you would have to build infrastructure to listen to those events. And then once an event is fired, you would then need to go back to the chain again to query relevant data and state to perform actions and then write transactions back to the chain. But with Somnia, the node handles the events and the data delivery automatically. So that's what removes the need for custom indexing infrastructure. You don't need to worry about relayers, and the protocol itself is guaranteeing that reactivity. And every node supports real-time subscriptions out of the box. We think this is a fundamental property of Somnia going forward. The schema-backed storage contracts is basically how you write that data to the node. And so we have essentially 2 types of contract built into Data Streams. One is the storage contract, which is essentially a simple KV store. You can imagine it being very similar to something like Amazon Firebase. And then schemas are basically how you structure the data that you write to this KV store. So if you register a schema, then that schema ID is used to encode the data on chain and decode that data. It is technically possible that you could write a schema that is sort of private to you. So that data is written on chain, but only you can decode it using the schema ID. However, I think it'd be much more beneficial for schemas to be open and discoverable, folks to sort of be able to find and compose new markets and applications out of the data that is on chain. So you could imagine having things like a player schema here in terms of properties about their game profile. You could write experience points, updates to that player ID. You could think about the GPS example that I talked about before. Sports like Formula One that I'm a big fan of, so I keep coming back to this as an example. Incredibly rich amount of telemetry comes out of those cars. You know their exact location. How much the driver is pressing the brake pedal. There's lap times, sector times, pit stops, what tires they're on, tire wear, brake heat, all those sorts of things. You can imagine those becoming properties that are written to chain that allow people to compose, real-time prediction markets or place bets on specific things like how long will the next pit stop be, what tires will the driver switch to. And you could compose those markets mid-race and have visualizations that are using that on-chain data to show you a top-down map of the race as it's happening. And so this allows you to essentially assemble data sources out of different sources and build and share each other. So if games coalesced around a single player schema, for example, or achievement schema or a leaderboard schema, you could imagine being able to compose cross-chain leaderboards across ecosystems of games, or companion applications that demonstrate sort of players' gamer score type thing, where numbers of achievements earned across various different games. And then the next thing is the automatic event emission. So this is the ability for nodes to emit events with additional metadata automatically. So you write the data to the storage contract, an event on that data update is emitted by the node, and subscribers to that data are notified instantly via WebSocket. In traditional event management, you would then have to go back and find supplementary data. But one of the things you can add to this subscription is the ability to query supplementary data automatically. So if we go back to my Formula One example, you may go, oh, this person has set the fastest lap time, return the previous fastest lap time by any other driver, during the race, or return the career wins of the driver that's just won the race as part of the event emission. So again, we're removing round trips to the node so that everything you are doing is as up to date and verifiable and on chain as possible, and removing that need for infrastructure to take data, react to it offline or off chain, and then right back to the chain. So I have this example here, and I may regret this, but you can all go and try this out for yourself. This is a very simple version of something like Reddit's r/place that is using data streams now. If you have a wallet attached to Somnia testnet, you can connect that and you can start placing pixels on this grid. And if everybody starts doing it, you'll be able to see just how quickly the pixel state actually updates. Let me just paste the link to it in the channel. Please do. I won't be able to paste it in the channel. Hopefully someone will paste it in the channel. But you can see the address here. Place pixels, you won't be charged any testnet tokens. It's using my wallet in the background, and you can start to see a real-time example of on-chain reactivity. So how does this work behind the scenes? Well, this is how you would do something like this in a traditional way. You would have a user that clicks a pixel. Say that pixel is then saved to the blockchain, is written to the blockchain, and then every other instance of that application will be pulling the chain for updates. Is there any updates? No. Is there any updates? No. Is there any updates? Yes, there's a new pixel. And then you would take that data and you would show the new pixel. And that is quite expensive, and it doesn't really scale that well because every user who's interacting with your app is then triggering more and more polling. So how would you then simplify that with data streams? Well, the next situation is this, which is using the reactivity. So you would place a pixel, the pixel is saved, and an event is emitted on chain. Every other instance of the application is subscribed to that event, so it gets notified that there is a change, and then you would go back to fetch the full canvas state and display it to the user. So that's an improvement. We're no longer polling the chain every second or few seconds. So we've reduced that amount of cost, but we still need 2 round trips because we need to react to that event and we need to go and fetch the canvas state. So with the ETH calls that I talked about earlier, you can change this once more to say, when a pixel event is emitted, send every other client that event plus the board state. And so in one single call, you're getting the event and all the information you need to update the canvas. And that means, as people place pixels now, it is instantaneous and extremely lower cost to run an application like this that generates those types of events. Hopefully that makes sense. I tried to find the simplest solution of that. So what's coming next? Like how do we build on this? This is what's currently available on testnet, and we're gradually working on documents. We'll make the SDK more widely available. It'll be an NPM package, but there'll also be API endpoints that you can inspect. We'll have an open source repo for that, and we'll have documentation. but there's more stuff that we want to do to improve the developer experience. So one of these is relatively simple, which is session keys. So when you're dealing with something that is high frequency, and the user is producing lots of transactions on chain in one go, then we want to make sure that they have a sort of seamless Web 2 style UX. So rather than having to authorize every movement you take in a video game, you would grant the application permission to write those events to you on your behalf. Your user's still in control. They would can revoke access at any time, but ensuring that people can send messages, place items, stream data continuously, like these sorts of things, just make the Web3 integration more invisible and more user friendly. Now, here is the really cool thing that we're working on, and this is on-chain reactivity. So everything I've talked about so far is about the idea of you getting events and the supplementary data that you need, and then deciding what you want to do with that and writing that back to the chain. So let's say you've got a loyalty app or something like that, where you like a post on social media, and that would emit an event saying this person's liked a post on social media, and then a server would determine that post deserves a NFT minted reward, and so then it would write back to the chain, please mint this user an NFT badge. Now, with on-chain reactivity, what can happen is you can have smart contracts on-chain that can subscribe to those events and react to them directly. And that unlocks just an incredible amount of potential. So one is, again, reducing your server infrastructure costs and logic, but also having sort of a verifiable history of how decisions were made fully on-chain. So in this example, you would like a post and it would immediately auto trigger the minting of an NFT. But let's use the example of the Somnia testnet faucet as a good way of explaining this. Currently, if you want to ask for testnet tokens from the Somnia faucet, you would give them your wallet address, and it would test whether you qualify that. And whether you qualify that is you have to have less than 0.5 Somnia testnet tokens in your wallet currently, and you need to have not asked for tokens for 24 hours. Let's say, I don't know the exact details. Now, with something like on-chain reactivity, you could move all of that logic on-chain. You could emit an event that this wallet wants testnet tokens. That event would be auto-decorated with the current wallet balance of that wallet and the transaction history of when they last interacted with the faucet. And a smart contract could then arbitrate on whether that user qualifies for additional testnet tokens and send those users the testnet tokens fully on-chain. You can think about things like instant liquidations, where rather than having to worry about pulling your funds out of a situation where you're about to get liquidated, you can have smart contracts that subscribe to those events and automatically withdraw your funds when you need it. You could have autonomous game logic, where when players reach a certain XP level, that triggers a level up. Maybe that emits a new event that triggers the minting of a reward, or triggers the spawning of a new boss, or unlocks the ability to go to a new level. Think about it in terms of prediction markets, where you can create a contract that composes markets from different data streams. I think Lewis Hamilton will win this Formula One race while it's raining. Get weather data and Formula One data and propose a market that other people can engage with, and that market will automatically resolve in a transparent and verifiable way. I think this is the thing that's going to be incredibly powerful about data streams, and will unlock a completely different way of interacting with the event ecosystem. The blockchain is no longer data storage; it is a dynamic and reactive, almost an operating system of logic that can take these inputs and perform actions based on them. So let's go back to my pixel example. Let's say I want to, this first half of the diagram, I would so let's say rather than paying for writing pixels out of my wallet in the back end, users log in and authorize that pixel application to pay the transaction costs of placing those pixels, which they can revoke anytime, but they can click as many pixels as they want, and they don't need to sign a transaction every single time they do that. So that's the session-based signing. And then you have the idea that, let's say I want to build an achievement into this thing, where when the whole canvas is full of pixels, then I want to grant every user a NFT achievement for achieving that milestone. So I'd have a smart contract that subscribed to that event, automatically verifies that the event has happened, and then mints a reward NFT to the wallet addresses that contributed to that achievement. So again, another small example, but that's how I may extend that demo application to sort of demonstrate things like that. So let's sort of make this a bit more real. Let's think about some of the opportunities, because I think, like, our next step is to start, doing hackathons with folks who have great ideas for this. Start working with partners on how to bring this technology into their applications or into those ecosystems. So this is my sort of start of a 10 on, how you would bring technology like this to life. So you could imagine gaming is just such a rich example of this. There's so much data that can be emitted and used. There's so many challenges to building on-chain games where you have to confirm that transactions have taken place on-chain. You may have to have fallback solutions for retries or logic, because it takes time for that data to resolve on-chain. So you could imagine things like, let's say you have a world boss that multiple different player groups are fighting across, different lobbies or different shards of the game, but that boss has a single health bar. So you could have things like boss health updates, synced across all players. You could think about building companion apps that show more granular leaderboards than the game itself offers, that just for you and your friends, or just for you and this clan. You could think about obviously granting automatic rewards, but you could also think about subscribing to those data feeds for additional mods or community built analytics. If you look at something like World of Warcraft, all of those cooldown timers and things like that, you could imagine that being on-chain reactivity. You can even think about things like spectator mode and anti-cheat. Can you verify that this person, in our chunked game, could you verify that this person was able to mine this block, or were they too far away distance-wise, right? So you can also think about like verifiable cheat detection on here. And again, this is now a situation where you're not building your on-chain integration as parallel infrastructure. This is something that is actually starting to lower your Web 2 infrastructure costs as well. My Formula One race, I've talked about this so much, but I'm going to talk about it again. But like, think about companion apps that give you much richer views on the races. You could think about automated payouts for prediction markets. You could talk about companion app leaderboards, live positioning, lap time, historical comparisons, bringing in supplementary data, things like weather data. I think is super interesting in Formula One, which would go, okay, I'm going to use this weather data to make a call on whether, I want to place a bet on what kind of tires these cars might change into. And this is, there are applications, like traditional Web 2 applications, where you can place bets on who's going to take the next corner kick, how many free kicks are going to be in a match, things like that. But this is about making that data available in a way that you can build your own markets. You don't have to deal with sort of prescribed scenarios that are sort of computed ahead of time. This is something where, with that data being discoverable and accessible on chain, and being able to search through schemas and identify the data sources you want to bring into that market creation tool, it essentially democratizes the ability for people to create and promote interesting, unique markets. DeFi, I've talked about the automatic liquidation. I've talked about a lot of these actually as I went, but hopefully this makes sense. Being able to subscribe to price feeds, set orders, immediately pull out when things are going south. Very, very transparent sort of price history that folks can deal with. Like, you're no longer waiting to call those contracts. Those contracts are acting on their own behalf. You start to be able to build autonomous logic. And then, games, DeFi, these are very obvious things, but you can also think about things like supply chain management. I have a Raspberry Pi behind me that talks to planes going overhead with a little antenna, and I send that data that the planes send me off to Flight Radar. Flight Radar give me a nice enterprise subscription to their services in return for the data that I share. I could imagine creating a schema that is identical to that event format and writing my flight data on chain that other people can query, make visualizations about, all sorts of things like that. So there's opportunities to build like real-time tracking on chain that verifies sort of handover of goods. You could think about building in like automatic customs charge contracts, things like that, automated payments, and then like consumer apps that do it. And you can imagine, because these are consistent schemas, that these would be viewable across industries or logistics suppliers, things like that. So that is it. It was a bit of a whistle-stop tour, and I hope that all makes sense. But yeah, I mean, I hope you can tell that I'm pretty excited about this. There's a website, datastreams.somnia.network, that you can go to. It's pretty lightweight at the moment. Gives you a TLDR of what I talked about today. You can sign up to the mailing list there, and then we'll send you blogs. We'll let you know when the SDK is available, when the docs are out, and the docs will be added to the standard Somnia docs as they land. So that should be great. So yes, that is it for my slides. I'm happy to start talking a little bit through comments and questions. Let's have a look.
Nice. Let's see here. I know Adrian had one a little bit earlier. Where did that go? There you go. Does data streams only work with data from Somnia, or can it be used to stream on-chain data from other chains?
So the ability to write data to chain is, like most things at Somnia we strive to be sort of EVM compatible. So there are components to things like writing data that are just it's basic smart contracts, but the reactivity, the subscriptions, and the push notifications are native to Somnia. They're built into the Somnia node. So you could imagine the idea of being able to subscribe to events from any contract via a Somnia node, if that makes sense.
Awesome. And then Melvin, I see, has a series of questions. He's building an InfoFi content creation network. That's a very quick way to put it. I'm sure he's like in his room right now, but let me pull this up. So building a social content creation application. What I want to do is have a live basis pull news information from. Okay, so it looks like another one. Content creation, where AI agents create ready-made social media content for users. They can directly post pulls from live news on events, trends from social media to create content. Can we pull data from centralized platforms? Can we enable crawlers? Is the first part of the question.
Yeah, so that's sort of the interesting thing that is sort of one step up the chain, right? So there's writing interesting data to chain that in structured formats that you can then react to and build on and subscribe to. But the question is, what is that data? How does it get on chain? And I think that is sort of a question for the community and partners on like what is the best structure for data of different types. So you could imagine maybe if there was a web crawler that summarized news and events, there was a clear structure, like this is the source of that news story, this is the URL it was found from, this is TLDR summary of it. So you could imagine having schemas that are around like news and information. But ideally what would happen is you would be able to have different data sources who are emitting their data on chain in a way that's easily discoverable because they're using schemas, and then you can assemble from a variety of different sources interesting information. Now, so the question is often, if you want high quality, high speed data, that usually costs a lot to collate and assemble and clean and process and host and serve. And so you would find things like market data or sports telemetry data behind an API, and you would have to pay for sort of rate limits and things like that. So that's a sort of interesting economics question about how this is going to work. And one of the things that we are looking at the moment, we haven't quite resolved this, but we have some good ideas, is how do you reward high quality data emitters? And essentially the way we're thinking about it is when contracts subscribe to different types of data, they're essentially paying a gas fee to deal with the event emissions and with the actions that take place based on that. And so we're looking at the ability for essentially a gas kickback to the data emitter based on subscribers, what they subscribe to, what kind of actions they're doing, the frequency of that subscription. And so essentially you can think about there being a gas incentive to putting data on chain. The more subscribers you have, the more people are doing interesting things with that data, the more of a kickback you're getting. And that is something where you, like particularly with particularly valuable data, making sure that there is a real incentive to produce trustworthy, high quality and high speed data is really important. So that's sort of the economic question that we're talking about in terms of the design of the on-chain reactivity. Hopefully that makes sense. It sort of moved around the goal there, but these are the sort of levers that I would think about pulling in terms of this project or this question.
Second part to it, how quickly can I pull external data into my application so that I can make it available to my node runners?
So I mean, you can see on the Somnia canvas, how quickly it is to, like, how quickly your application updates when an event is emitted. It's extremely quick. Like it takes more time to write the pixel there because I'm doing a transaction and I'm doing some data cleaning than it is to view it. And put two windows of that Somnia Place app side by side and place a pixel and just see how instantaneous that update is. It's milliseconds. So the other nice thing about it is when you are getting an event and you're reacting to that event and fetching data, if you're fetching data separately, you may be talking to a node that it isn't up to date with the event that's emitted, right? Especially on testnet, you may have some lag there between nodes. The fact that you're appending data to the event that's emitted guarantees that data is coming from that node, which means that data is up to date with the event. So that's another thing that's nice. You don't have in a previous version of this application where I would be polling the node, I might be fetching, different states of that pixel canvas. But here, because I'm attaching that state to the event that's emitted, I'm always up to date. And that's another way of sort of adding the robustness to the data being fetched.
Awesome. So let's see, makes sense. We can add that to the node since we're already incentivizing them to create content. Cool. So it sounds like that did answer that.
Cool.
Guys, any more questions from the audience that you'd like to have answered by Oliver for Somnia Data Streams? Looks like we are pretty much there then, Oliver. Want to thank you so much for the workshop. Think that, again, everybody that's in the incubator will certainly be in some way, shape, or form either thankful that they have the information or be implementing it directly. So
Great.
kudos to you guys. Yeah, man.
Well,
and anything else you want to say to the audience or tips you might want to give the builders that are out there engaging with it for the first time?
So I think that's sort of like the interesting thing, and this is a journey that we're going on, as we build this app, and we need to sort of kick the tires and prove it out. I think there's sort of two ways of approaching this. In a video game world, the economy of data and events is often a closed loop, right? You're building the application that's emitting the data, you're performing calculations, etc., on that data, and then writing that back to your own application. So I think it's always interesting to use that as your first proof of concept. Is going, okay, this is the data I want, this is the structure I want it in, this is how I want to visualize it and use it. So I think that is like always the natural first starting point for something like this. But I think the interesting starting point, or the interesting sort of next step, is going to be, okay, so I now understand how to subscribe to those events and what kind of things I want to solve. How can I find new data sources? Like what's existing on chain? Like we want to build something like a schema explorer, right? The ability to say, right, these are the schemas that already exist. You could just write to them from your app. You never need to touch, Solidity or register a schema or worry about those sorts of things. I can already write to this thing because somebody's already made it for me. So like the ability for the community to build maximally useful schemas that other people can reuse, and essentially being able to set the standard for like, what does a game achievement mean on chain? What is level? How do we track experience? How do we calculate ELO, right? Imagine ELO calculator, being something that multiple games could use and rip off in their own context. So I think then there's the kind of data that I'm emitting, is there a general format that makes it useful for other folks? Because then once other data sources are using the same structure, then you can start composing really interesting stuff at the end of it. And then I think finally, yeah, sorry, I'm just trying to think how to think about it. Yeah, I'll leave it there. Yeah.
So it sounds like we'll probably be doing some schema-related community building activities in the very near future, right?
Right.
Which, speaking of, we have for those of you that are watching that may be coming to DevConnect in Buenos Aires, we are super excited to announce we're going to be doing a mini sprint vibe coding hackathon on Somnia Data Streams. We have Vercel and V0 joining as the AI partner or LLM to help vibe code these things out. Believe there will be a prize pool. I think, don't hold me to it, but up to 10 grand across 3 main winners. And it should be an absolute blast. For those of you that are in Dreamathon that are going to be on the ground, come say what's up. Come get to know the Somnia team. Again, you're going to be super blown away by not only how responsive everything is, but how fast and how active the community is at the same time. So for those of you that are new, follow the Dreamathon account. Give the Crack Labs account a follow also. We are super excited to see everybody in the next couple of weeks. And if you have any questions, drop them in the Discord. Oliver, thanks again, man. It's been fun.
Thank you. Looking forward to seeing what folks build.
Oh, yeah, it's going to be awesome. Till next time, guys.
Take care.